Okay, Assalamualaikum warahmatullahi wabarakatuh, and very good day. So for week 7, part 1, we will focus on a new topic, but it's not so new because it's actually is the advance of hypothesis testing for one population. And for now, we will study about estimation and hypothesis testing for two population. Okay, some books said that is because we have two group of sample. Alright, so for the first part, today is inferences about the difference between two population means for large and independent sample. Do you understand about independent sample? Independent sample mean dia macam there's no relationship between that two sample or group of the two sample. Kalau dependent sample is about macam before and after. Okay, the same group, we will kaji tentang before and after, something like that. Right? So same goes to population. We will study about the mean of x bar 1 minus x bar 2. Right? So okay. So just do something like this. Okay. So let's do this. One population. Why? Okay. Hopefully there's no problem. Okay. For one population, or population, like yang kita dah belajar before this, we will study about the inferences, the estimation. Okay, today we will learn about two population. So I will put another sorry. It's okay. So population and two population. Right. So okay, let's do something like this. For one population, we study. Remember, we learned about the difference between parameter and statistic, and we estimate the value of parameter by the value of statistic. Same goes to for two population. All right. Some revision about what we have learned before about one population. If we want to estimate our mu S bar, our mu, so we take the value of x bar. Okay, and if you want to estimate the value of sigma, we take the value of S O, variance, very simple. Sigma, we take the value of S. Okay, for one population. This is about all this. All this is we call as a parameter, and this is the value of statistic. Okay, so statistic we get from the sample and the parameter from population, but we estimate the value of parameter by using the value of statistic. Same goes to population, right? So why is we use term different? Okay, so jangan keliru, jangan rasa susah bila ada perkataan different. So the mean of x bar 1 minus x bar 2 denoted by mu of x bar 1 minus x bar 2 is equal to mu 1 minus mu 2. And the standard deviation of x bar 1 minus x bar 2 denoted by sigma of x bar 1 minus x bar 2 is equal to the same apa yang ditunjukkan dalam table ini, right? So ini yang kau kena highlight, this one. Okay, if we don't know the standard deviation of sigma 1 and sigma 2, but we have a point estimator. Alright, so ni pun kena highlight. So the interval estimation of mu 1 minus mu 2 is apa yang ditunjukkan dalam table. Kalau kamu perhatikan betul-betul, is almost similar apa yang kita belajar sebelum ni. Okay, so remember, if dalam kita ada point estimate kan, so still remember mu, the point estimate dia adalah x bar. Variance sigma squared, the point estimate adalah S kuasa 2, manakala sigma dia punya point estimate adalah S. So sama juga dengan two population. So the point estimate for one population adalah x bar 1 also or x bar plus minus, if we know ataupun the value of sigma is known or given in the question or the problem, so we can use table Z. Alright, and the point estimate of sigma x bar adalah, saya boleh rewrite this one as a S bar plus minus Z alpha per 2 sigma over square root of n. This one, if sigma is known. If sigma is unknown, but the n is large, so we will use the point estimate of sigma as bar plus minus Z alpha per 2 S over square root of N. Alright, this one for one population. So for two population, okay, kalau for two population, alright, here, okay, for two population, dia tak ada beza banyak pun. So dia akan jadi, because we have two group of sample, so x bar 1 minus x bar 2 plus minus, we will apply a Z distribution per 2. If sigma 1 and sigma 2 is known, so this one will be sigma plus, if not, we will use this. Plus minus Z alpha over 2 plus, but yeah, it's just a advance of what we have learned before. So yeah, let's take a look at our first example. Okay, so I keep this ruler. So example 1, the following information is obtained from two independent samples selected from two population. So they give you information about the sample size, x bar 1, x bar 2, and also the standard deviation of both samples. So take a look at A. Determine the point estimate of mu1 minus mu2. As I told you before, if you want to get the point estimate of the mu or mean population, we will estimate them by the estimator. Estimator is our x bar, the average of sample. So how to answer this? We just take both average for both sample, and then you just calculate the difference between those two values. So x bar 1 minus x bar 2, use calculator, 5.47 minus 5.10. So that's your point estimate. Okay, so I repeat, the point estimate of two independent sample is you just take both average and get the difference between those two values. So 5.47 minus 5.10 is 0.37. So with that, we complete this first exercise. Okay, so for B, construct a 99% confidence interval for mu1 minus mu2. So A asking you about the point estimate, and for B is asking you the same thing like we have learned before, which is we get the interval. Alright, the point estimate and interval. So remember, the formula to get the interval is you just add the point estimate Okay, so our formula, okay, kalau nak dapat interval, sorry. Okay, so the formula to get the confidence interval for difference between apa kita panggil kat sini ayat dia, difference between two population means is, okay, simple way to remember is the point estimate plus minus error. Okay, so you know that the point estimate, the different for one sample is one population is x bar plus minus z alpha over 2 sigma over square root of n. So untuk two population, they just follow that formula. So our point estimate is the difference we take from A, x bar 1 minus x bar 2 plus minus error. So our error is z alpha over 2 and followed by okay, so we just substitute that value or the given information to the formula. So apa yang crucial is how to get the value or the critical value. Alright, so for B, construct a 99% confidence interval. You know that we want confidence interval 99%, so your alpha is 1%. So since we want to get the confidence interval, so that alpha you have to divide by 2. Alright, so take this one. Right, so kita bagi 2, 0.01 bagi 2 adalah 0.005. Remember, there's no negative value for area. Right, the negative is because of it's situated at the left hand side of 0, less than 0. Right, so okay, I will help you how to get this one. So remember, the area after we divide by 2, we get this value 0.005. Right, so saya buat besar sikit. Okay, kan 0.005 sama juga kat sini. So it's up to you. You want to refer positive table or negative table for Z distribution, but for me I prefer negative table because we don't have to take 1 minus the area. Alright, so 0.005, so we refer to the table. So I give you the normal distribution table. The positive value you have to 1 minus the area, right? But for negative, we just straight away take a look at the table and we try to get the value that nearest to the area that we have calculate. So 0.005 is between 0.0051 and 0.0049. So like I told you before, the answer will be negative 2.575. So here, so that's our critical value, 2.575, negative 2.575. Why we set that as a critical value. So I will use this starting from now. Z, sorry. Okay. Okay, our ZC critical value is equal to this. So saya ambil ni. Okay, we call it as a critical value. Same goes to negative part. So saya pindah sini. Okay, so dengan negative ZC. Right, so critical value, why we call it as critical value? Because if the test statistic value that we count at step 3 is on this point or here or in the rejectional area, so this we call as a rejectional area. Same goes to this part. Okay, rejectional area. Okay, so that's why we call it a critical value. So we already get the point estimate here. We already get the critical value plus minus 2.575, and we get from the information about the value of both variance or both standard deviation and also the sample size. You just substitute that value, and yeah, that's the answer for the interval. Alright, so that's the answer. Okay, so we complete example 1. Okay, so kita boleh tanda kat sini. Complete. That's how so complete. Alright, so let's continue with our second example for this note. Okay, a bottling company has gathered information regarding the diameter of bottle produced by two machines, M and N. A sample of 70 bottles is taken from machine M, and they give an average diameter of 8.56 centimeter with a standard deviation of 0.5619. So if I were you, I will gather all this information. So this is so kita highlight kat sini lah. Kita highlight the sample size. Okay, the next circle size is here, and then we take average for M and average of N, and last function we have this one, standard sorry standard deviation and also standard deviation. Right, so okay, so A, yeah, soalan sama. Let mu1 and mu1 be the two population means of diameter of bottle, blah 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 blah. Determine the point estimate. So highlight the question. They ask you about what is the point estimate? So saya rasa kamu semua tahu the point estimate for difference of two population means is x bar 1 minus x bar 2. So you just take 8.56 minus 8.78. Okay, so saya dah buat kan. So the value is negative 0.22. So we complete this one. So B, determine its margin of error. The same goes to in one population. Alright, remember the formula for margin of error. So kalau siapa lupa, saya tulis balik kat sini. Okay, margin of error is especially on alpha equal to 0.05, right? So kalau siapa yang masih ingat, tak perlu buang masa, you know that alpha 0.05, the value for z alpha over 2 or critical value for this is plus minus 1.96. Alright, so how to calculate the margin of error is for two population, z alpha over 2 s1 squared n1 plus s2 n2. Alright, plus minus. That's our MOE. Okay, so yeah, after all, after I complete dah lengkapkan, the answer supposed to be plus minus 0.1995. Right, so to complete for B. And last, C, construct a 97% confidence interval for mu1, mu2. It's not a good question actually. Supposed to be, it's related to B. So construct a 95% to okay. Alright, but it's okay, but you just follow the question. Construct a 97% confidence interval for mu1 minus mu2. So sama je macam sebelum ni. So if they want confidence interval 97%, so kat sini kita confidence interval 97%. Okay. So alpha is 0.03. You just follow the same procedure. You divide by 2. You have to get the Z critical for both side, both tail, and the value after you divide by 2 is 0.015. The area is 0.015. It's up to you to refer to which table, positive or negative. But as for me, I prefer negative table. So I try to get the area which is nearest to 0.015. So I refer to table Z, negative 0.05. Yeah, the exact value here. So here 0.015. So gunakan pembaris, we dapat negative 2.17 because it's symmetrical. So both critical value is negative 2.17. Betul ke? Okay. Betul. Negative 2.17 for, okay, kat sini samalah ZC, negative ZC. This one is ZC. Alright, so yeah, follow the same procedure to get the interval, and that's the answer for the interval for 97% confidence interval. Right? So we complete A, B, and C. Alhamdulillah for example 2. Okay, let's continue for example 3. According to a report of technician, the mean time spent by student using internet in lab A is 20.6. Blah blah blah. You just baca soalan, and then soalan ni semua sama je. Determine a point estimate, construct a 90% confidence interval. Okay, so you just follow the same step. I'm sure there's no problem for you to understand the early part of this topic. Alright, so our aim for the first video is to get the point estimate and also the confidence interval. Alright, so please refer to example 3. Yeah, okay, we complete example 3. Okay, and also okay, so after all, we already complete example 1, example 2, and example 3. You can do that by your own by referring to the solution that I gave you. So this is all all about for our first video for week 7 part 1. So if you have any problem, just try to reach me. Alright, take care. Okay, Assalamualaikum.